Okay, good morning everyone. Today we'll look at factor by grouping. So for the last several days we've been multiplying polynomials and dividing polynomials, but that all has been done for one specific purpose, and that is to being able to find the zeros of a polynomial function. Okay, we've been given the zeros or the factors and we've written polynomials, but now we need to go in reverse, starting with a polynomial function. We'll have to find the zeros, just like we did in Chapter 5. So we did not go over factor by grouping in Chapter 5. That was not introduced in Chapter 5, so I will go over factor by grouping today. And that will be the last factoring technique that you will be responsible for or need to know before we actually find the zeros of polynomial functions, particularly those with degree higher than 2. Because we've only looked at quadratic functions or finding zeros of quadratic functions. Now we're going to be finding zeros of third degree polynomials, fourth degree polynomials, fifth degree polynomials, and higher. So let's review some of the methods of factoring we have covered. So we have factored by factoring out the greatest monomial factor. And I'll go over each of these examples. Okay, so pay attention here, and then you'll have some problems to do as I go over them. Again, this is review, so you shouldn't have too much difficulty after I show you the first problem here. So let's say here I have an example, 16x cubed plus 4x squared, and I want to factor that. So to recall, we factor out the greatest monomial factor. So what we look for is we look for values of the leading coefficients for each term, 16 and 4, a factor that we can divide evenly into 16 and 4, and that is 4. And to recall, the factor of the variables, the largest factor that we can divide x cubed and x squared by, if you recall, is always the variable with the smallest exponent. And here we have 2. So I can divide each of those terms by x squared. So my greatest monomial factor then is 4x squared. And then we just include what we have left over. So 16 divided by 4 is 4. And then x cubed divided by x squared is x. And then I have my plus. And then 4 divided by 4 is 1, and x squared divided by x squared is 1, or any number divided by itself is 1, so we just have 1. Okay, so when I factor 16x cubed plus 4x squared, I get 4x squared times 4x plus 1. And again, we've done this many times in Chapter 5. All right, so what I want you to do, I'll give you a couple minutes here. I want you to factor 15x to the fourth minus 3x squared. And then I want you to factor 20x cubed plus 4x squared. So pause the video and factor those. Okay, you should have gotten, let's see here, the largest or greatest monomial factor for 15x to the fourth and 3x squared. I can divide 3 into both 15 and 3. So, and I can divide x squared into both x to the fourth and x squared. So my greatest monomial factor will be 3x squared. And then what I have left over will be, so 5x squared. 3 times 5 is 15, and x squared times x squared is x to the fourth, and then minus 1. 3x squared divided by itself is 1. All right, and then number 2, the greatest monomial factor would have been, let's see here, it would have been 4x squared. And then what would be left over is 5x 4x squared times 5x will give me 20x cubed, and then plus 1. Okay, so again, just review. Factoring out greatest monomial factors. Now let's look at factoring trinomials. So what was the other thing? So factoring trinomials. And just to recall. So here they give us an example. We're actually finding the zeros, but nonetheless we have to factor x squared minus 4x minus 12. We factors of negative 12 that add up to a positive 4. That would be plus 2 minus 6. So we write x plus 2 times x plus 2 times x minus 6. And then we found the zeros by setting each factor equal to 0. So my zeros were negative 2 and 6. All right, so again, pause the video and let's factor or find the zeros for those two. X squared minus x minus 6 and x squared plus 7x plus 12. Okay, so let's see or check your work. And we should, so that should, we'll set f of x is equal to 0, and then factors of negative 6 that add up to negative 1. Well, that would be x minus 3 times x plus 2. And then if we find the zeros of each, x minus 3 equals 0, x equals 3, x plus 2 equals 0, x equals negative 2. Okay. All right, and then number 4, again, we have to set f of x is equal to 0 and factors of 12 that add up to 7. That would be x plus 3 times x plus 4. And to find the zeros, x plus 3 equals 0, x equals negative 3, and then x plus 4 equals 0, x equals negative 4. All right. So again, just review. Factoring out greatest monomial factor, complete. Factoring trinomials. And then the last one to recall is factoring difference of squares. So remember, difference of squares, a squared minus b squared is equal to a squared minus b squared is equal to a plus b times a minus b. So here they wanted us to find the roots by factoring, so we have to set one side equal to 0. So we subtract 25 when we get 4x squared minus 25. Okay, so to recall, we notice that 4 is a perfect square. We have a difference. We have minus, and 25 is a perfect square. So we take the square root of 4x squared, and it gives us 2x. And then we take the square root of 25, and that gives us 5. So that's my a. My a is 2x, and my b is 5. So when we factor that, we'll get 2x plus 5. Using the difference of squares, 2x plus 5. A was 2x, and b was 5. And then we'll get 2x minus 5. A was 2x and b is 5. And then we set each factor equal to 0. And we solve. So we got x is equal to plus or minus 5 halves. Okay, so pause the video and do 5 and 6. Okay, so we want to find a 0, so 0 equals 9x squared minus 49. 9 is a perfect square, and x squared is a perfect square, so my a will be 3x, and then my b will be 7. So when I factor that, I'll have 3x minus 7 times 3x plus 7. And then when I find the zeros, I'll have x is equal to 7/3 and minus 7/3. Okay, remember to find the zeros, you set each factor equal to 0. So 3x minus 7 equals 0, 3x equals 7, and x is equal to 7/3. 3x plus 7 equals 0, 3x equals negative 7, x equals negative 7/3. Okay. And then number 6, so we have 0 equals, so again, square root of x squared is x, and then the square root of 16 is 4. So we will have x minus 4 times x plus 4, and then my zeros would be 4 and minus 4. All right. So there. Now, and this is all leading up to factor by grouping. So believe it or not, everything we have been doing so far, and this is why I'm reviewing, all the factoring we have done, factoring out greatest monomial factors, factoring trinomials, factoring difference of squares, that will all be required to do when we factor by grouping, okay? So, now, before we actually get into factor by grouping, again, so and this will come up a lot, we always have to, anytime we factor, we want to factor out the greatest monomial factor before factoring. That's going to be so important in factoring by grouping. So, again, factor before you factor. Rule number 1. Rule number 1 of factoring. Rule number 1 of factoring. Factor before you factor, okay? Factor before you factor. Boy, that's this is like a grease board. All right, so let's take a look at, example here. So here I have a 50x squared minus 2. So I ask myself, what's the greatest monomial factor? Well, I can divide both 50 and 2 by 2, but that's it. I don't have an x squared, or x, in my second term. And so the only thing I can factor out is 2. But that leaves me, I want you to notice, is 25x squared minus 1. Now you may be tempted to think I'm done factoring, but you're not, okay? Because now I see that I have a difference of squares. Okay, 25 is a perfect square, and x squared is a perfect square variable, and 1 is a perfect square number. So when I factor this then completely, so this will be 5x minus 1 times 5x plus 1. Done. I can factor no further. You will see that will be extremely important in factoring by grouping. In fact, everything I have gone over so far will be important when we factor by grouping. All right. And as another example here, so I see I have 50x cubed minus 48x. Again, I'm looking for the greatest monomial factor. Okay. So let's see here. The largest number I can divide evenly into 27 and 48, that would be 3. And then the greatest monomial factor for x cubed and x, remember, it's always the variable with the smallest exponent, so that would be 3x. All right, so when I factor this, I have my greatest monomial factor is 3x, and then here, let's see here what I have left over. 27 divided by 3 is 9, and x cubed divided by x is x squared. And then 48 divided by 3 is 16, so I have minus 16. And x divided by x is 1, so 48x divided by 3x is just 16. Now again, you may be tempted to think that you are done, but you are not. Because I see there I have underneath 27x cubed minus 48x is lurking a difference of squares. Okay, so when I factor this then, completely, 9 is a perfect square number, and x squared is a perfect square variable, so I can factor this 3x minus 4 times 3x plus 4. Completely factored now. Okay, so pause the video, and then I want you to do 7 and 8. Okay, in 7, I can't. There's no number I can divide evenly into 4 and 25 other than 1s. But for the variables, my greatest monomial factor is x. So when I factor this, I'll factor out an x. And that will leave me then with 4x squared minus 5, in which case I can factor some more. It's a difference of squares. 2x minus 5 times 2x plus 5. Okay, and then the last one here. So let's see here. The largest number I can divide both 24 and 54 by, well, let's see here. That would be 6. Okay. And of course, the greatest monomial factor for x cubed and x would just be x. So there. So I can factor out a 6x. So there. So this will be 6x, and then what I have left over is 4x squared, and then minus 9. And again, I'm not done factoring. This will be 6x times 2x minus 3 times 2x plus 3. Done. All right, so I have reviewed everything with you. And again, this is just what we did last trimester, or yep. So now we can look at factor by grouping, but you will see that when we do factor by grouping, we will do everything we have just done, okay? So let's look at factor by grouping. What do we mean by factor by grouping? And some of you have seen this before, okay? Not with me, but you've seen this in like Algebra 1. So factor by grouping says we're going to group some terms. So I'll group x squared, or x cubed, and minus x squared. I'll group those terms. And then I'll group 25x and 25. They actually say negative 25x and 25. Okay, so, but I don't quite look at it that way. All right, so as a student, I always found factor by grouping really easy to do, because once you factor the first group, you'll find a factor for the second group. It works like that all the time. So you'll see what I mean. So here I have x cubed minus x squared. So I have x cubed minus x squared. So I want to find the greatest monomial factor. Okay, well, that's just x squared. So when I factor this, then I'll have x squared, and then what's left over is x minus 1. Okay, so that's what they did. So they factored out an x squared, and they got x squared times x minus 1. So that's that grouping there. Now, as I was saying here, factor by grouping, they always give you a hint. And you know what that hint is? That hint for the other, so when you go to factor the other group, 25x plus 25, your hint is x minus 1. So what do I mean by that? Well, you just come on highlighter. Okay, so what I mean by that, so there's my x minus 1. Well, you just write x minus 1 over there. Okay, that's what I mean. The x minus 1 is a hint for the other group. So they always give you a hint. All right, and so then all you have to do is decide what do you need to multiply this x minus 1 to get what you started with, and that was minus 25x plus 25. Well, all I need to do is multiply it by negative 25. Okay, negative 25 times x will give me negative 25x. And then negative 25 times a negative 1 will give me a positive 25. Okay, so I always found factor by grouping pretty easy to do. Okay, I'll go back over that. So we had to factor x cubed minus x squared. So we factored out an x squared. And then we're left with x minus 1. And then I'll use that x minus 1 as a factor in the other group. And I'll write it that way. And then I have to figure out what do I need to multiply x minus 1 by to give me what I started with, negative 25x plus 25. Well, I have to multiply it by negative 25. And then what we do, now we group our factors. So here, So I have an x minus 1 and an x minus 1, so I'll write that there. So that's my x minus 1. And then my other pair of factors would just be x squared minus 25. And I'll write that there. Okay. Right. And some students have difficulty with that, but you know, if I had x squared times a minus 25 times a, and I factored out an a, well, what would I have? I would have a times x squared minus 25. So a just happens to be, in this case, x minus 1. Okay? So students will say, well, where did the x squared minus 25 come from? Well, it came from like that example there. We factored out an a, and we had left over x squared minus 25. A just happens to be x minus 1. All right, now I want you to notice though, but we're not done factoring. Okay, we're not done factoring because now here, this x squared minus 25, I see I have a difference of squares. So completely factored, x cubed minus x squared minus 25x plus 25 will give me factors of x minus 1 times x minus 5 times x plus 5. You'll recognize that as a third degree polynomial, and then now you'll see you'll be able to find the zeros of each factor, 1, 5, and negative 5. There. So this is where we're going with this here. Factor group by grouping is going to help us find zeros of higher degree polynomials other than 2, degree 2. All right, and so let's look at one more example here. Okay, so again, factor by grouping. Okay, so I want to treat this as one group, and then I want to treat this as one group. So from the first group, I'll factor out x squared, and that will leave me with x plus 1. There's my hint, x plus 1. And so now I'll just write x plus 1 over there. They always give you a hint from the first group. And then now what do I need to multiply x plus 1 to get what I started with, negative x minus 1? Well, I just need to multiply by minus 1. Minus 1. All right, so from the first group, okay, so from the first group then, well, I'll have x squared minus 1. Okay, so x squared minus 1. And then the other group, I'll have x plus 1. If I completely factor that, again, so notice here I have a difference of squares. I have a difference of squares here. X squared minus 1, that's a difference of squares. That's x plus 1 times x minus 1. And then I have x plus 1 completely factored. All right, so what I want you to do is I want you to completely factor these here then. So let's see here, how many problems, so I have to number, because I'll be looking for this here, number 9. Okay, excuse me, I want you to completely factor x squared plus 3x squared minus 4x minus 12. And then number 10, we'll just go 8x cubed plus 4x squared minus 2x minus 1. Pause the video and do those. Okay, so from the first group here, I can factor it out in x squared. Oops, this should be x cubed. I can factor out an x squared. So let's see here, this is going to be x squared times x plus 3. And then there's my hint, x plus 3. So I'll write x plus 3 over here. And so what I need to multiply to give me negative 4x minus 12, well, that would be negative 4. And so then I'll factor x squared minus 4 times x plus 3. And when I factor this would be x minus 2 times x plus 2, because that's the difference of squares, times x plus 3. Okay. And then the last one here. So I'm going to factor out from that group I can factor out a 4x squared. And that will leave me with 2x plus 1. So again, I'll have a 2x plus 1 over here. There's my hint. And what I need to multiply by, I need to multiply by negative 1 to give me what I started with in this group here. All right, so then I'll have 4x squared minus 1 times 2x plus 1. And then I have a difference of squares, and that will be 2x minus 1 times 2x plus 1, and then times 2x plus 1. Okay, so that's where we're going here. So, and then we'll begin factoring by zeros, or to find the zeros.